Welcome you all. I want to discuss about a doubly reinforced beam problem. A concrete beam. So by working system method of design, we will analyze this concrete beam. Concrete beam of 400 mm by 600 mm effective. So 600 mm is effective depth is reinforced with 4 bars of 25 mm diameter bars on tension side and 4 bars of 20 mm diameter bar on compression side. Find the moment of resistance of the beam. Use M20 concrete and Fe415 steel. Take effective to the cover to the center of compression reinforcement as 40 mm and M is equal to 13.33. You consider modular ratio M is equal to 13.33. So first of all, we need to write the given data. Is given a doubly reinforced beam. So we have to draw the section first. Section. So this is section of a doubly reinforced beam. Width is given 400 mm and the 600 mm depth is given. This is not overall depth. Effective depth is given. Okay, effective depth is given. That is 400 mm. 600 mm that we need to write here. 600 and is mentioned that 4 bars of 25 mm diameter. 4 bars of 25 mm diameter is used as a tension reinforcement. And 4 bars of 20 mm diameter is used as a compression reinforcement. 4 bars of 20 mm diameter is used as a compression reinforcement. The moment, so he's asking to find the moment of resistance of the beam. Use M20 concrete and Fe415 steel. So we know that for M20 concrete, so M20 concrete in batti mana sigma CBC value different aitadi. The concrete in batti, grade of concrete in batti sigma CBC value different aitadi. For M20 concrete, sigma CBC is 7 Newton per mm square. Okay. For M25 it is 8.5. For M30 it is 10 Newton per mm square. So and grade of steel batti mana sigma ST value different అవుతుంది. So grade of steel for Fe 250 grade or Fe 250 ki 140 Newton per mm square is a grade of sigma ST value. For Fe 415 for 415 grade of steel sigma ST value 230 Newton per mm square. So in this given problem is given that sigma ST 415 కాబట్టి sigma ST value we have to consider 230, sigma CBC value to 7 Newton per mm square. That we have to write first. First and foremost thing is you have to write that values. So after that, so you have to write the given data and you need to calculate area of steel in tension zone and area of steel in compression zone. Right? Area of steel in tension zone as well as area of steel in compression zone you need to write. So here, one second. Yes. So B value is given, that is B value given. B is equal to 400 mm, effective depth D is equal to 600 mm, and D dash is given 40 mm, that is given in the problem. And also is given that modular ratio M is equal to 13.33, right? So now first of all we have to calculate area of steel tension zone, 4 bars of 25 mm dia. So now total area of steel in tension zone 4 into pi by 4 into 25 square, that is 1963 mm square we are getting. Area of steel in compression zone 4 bars of 20 mm diameter. So that we have to calculate total area. 5 by 4 d square area of 1 bar. So number of bars is 4. So 4 into 5 by 4 d 20 square. So 1256 mm square we are getting. 1256 mm square. So that is your area of steel in compression zone. Area of steel in tension zone. This is area of steel in compression zone. This is. So now we need to calculate. First of all, we need to calculate the neutral axis depth. Critical neutral axis. We need to calculate critical neutral axis. So neutral axis we have to calculate. This is can be calculated from the stress diagram. Equivalent stress diagram. Right. So this is stress variation. So this is your sigma CBC and the equivalent stress in steel, that of concrete. Equivalent stress of steel, that of concrete will be sigma ST by M. Sigma ST by M. So now from the similar triangle, so if it is N, this will be D minus N. From the similar triangles you can write sigma CBC by sigma CBC by sigma ST by N. Sigma ST by M is equal to N by D NC by, so let us say it's critical under about NC under. So NC by D minus NC. So first of all we are calculating critical. From this sigma CBC value 7 Newton per mm square and M value 13.33. Okay, and sigma ST value 230, that is given. So effective depth D is equal to 600. You substitute from this critical neutral axis depth. Critical neutral axis depth is 173.87 mm. Now we need to calculate actual neutral axis. Actual neutral axis we have to calculate. Actual neutral axis depth we need to calculate. So for the calculation of actual neutral axis depth, so we'll move to the transformed section. So just in the previous class we discussed about the transformed section. Once again, I'll show you the transformed section here, right? So for the transformed section, the neutral axis depth can be calculated b n square by 2 plus 1.5 m minus 1 ac n minus d dash. So this is a compression moment of resistance. If we equate compression moment of resistance and the tension moment of resistance, equate చేస్తే నీకు actual neutral axis depth వస్తుంది. We have to equate compression moment of resistance and a tension moment of resistance, then you will going to get actual neutral axis depth n. So this is the compression moment of resistance due to concrete and due to equivalent steel in compression zone. So this is steel provided in tension zone, equivalent steel provided in tension zone, right? Equivalent section, steel section, equivalent steel of that of concrete section, transformed section. And steel in concrete area convert చేస్తున్నాం. Steel strength అని concrete strength that equivalent area అని మనం డ్రా చేసి మనం జాస్తి ఇటు వస్తుంది. Modular ratio యూజ్ అదే అండి. ఇప్పుడు ట్రాన్స్ఫర్మేషన్ చేసుకోవడానికి మనం modular ratio వాడతాం. M into AST into D minus M. So if we substitute all these values, B is equal to 400, N is equal, N we don't know, we need to calculate. M is equal to 13.33. Area of compression steel, we need to substitute 1256, right? So D dash is equal to 40. AST, area of tension steel, 1963, 1963.49. You substitute all these values, N value, you are going to get actual neutral axis depth is 189.46 mm. 189.46 mm. That means actual neutral axis is greater than that of critical neutral axis. That means this is a over reinforced beam. This is a over reinforced beam. So in over reinforced beam, concrete will fail first. Concrete will fail first, right? Right. First of all, for the calculation of moment of resistance of concrete, we have a formula. M is equal to M is equal to moment of resistance is equal to moment of resistance due to concrete portion in compression and moment of resistance due to equivalent steel provided in compression zone, right? So this is compression steel anamata. M2 because of compression steel. So moment of resistance is equal to half sigma CBC B into N into D minus N by 3 plus 1.5 M minus 1 into AC sigma C dash minus. You need to remember this formula. You need to derive. Derivation చేసుకోవచ్చు previous class లో మనం చూసినాం ఒకసారి. Sigma C dash D minus D dash. If you substitute all these values, you're going to get the ultimate moment resistance of the doubly reinforced beam itself, right? That's it. So for the calculation of sigma C dash, again we need to use similar triangles concept. So top fiber is sigma CBC at this level. That means reinforcement will be provided in compression zone. At this compression zone reinforcement levels, that is sigma C dash will be we need to calculate. So from these similar triangles, this is N and this portion is N minus D dash. So sigma CBC by sigma C dash is equal to sigma CBC by sigma C dash will be equal to N by N minus D dash. So in relation from this you can able to calculate sigma C dash, that is stress in steel at this level. Stress in steel at this level you can calculate sigma C dash. Okay. So ఈ సిగ్మా సి డాష్ కావాలంటే మనం ఇట్లా మనం క్యాలిక్యులేట్ చేస్తాం. సిమిలర్ ట్రయాంగిల్ నుంచి మనం క్యాలిక్యులేట్ చేసుకుంటాం, రైట్? సో మీకు మూమెంట్ ఆఫ్ రెసిస్టెన్స్ వచ్చేసింది. సో దిస్ ఇస్ లైక్ దట్ విల్ గోయింగ్ టు క్యాలిక్యులేట్ మూమెంట్ ఆఫ్ రెసిస్టెన్స్ ఫర్ ది డబ్ల్యూ రెయిన్ఫోర్స్డ్ బీమ్.